Have you ever been looking for a Zener diode for a project with a certain power rating and you can't find it, and if you do find it, it takes 4 weeks to get here and it costs $50? Well, I've got a solution for the Zener Booster. The Zener Amplifier, controlling a MOSFET that shorts out your circuit with a Zener diode and a little analog digital thing. One of those. This is a circuit I thought of. I was bored at work one day. Which basically turns a MOSFET gate on, turns the MOSFET on, an NMOS, when the voltage passes a threshold which you tune by the size of a tiny Zener diode on a BJT transistor. So, yeah. Basically, I did this because I have a bunch of tiny Zener diodes that are good for a watt maybe, that are very precise, and no big power Zeners. And I need a power Zener to withstand about a 50 amp pulse for at least a couple milliseconds before a fuse blows. So if you could use the tiny Zener, but there's no guaranteeing it won't get worn out, as this failure mode will happen over and over again. I fix the fixtures. The technicians, they blow stuff up at work sometimes. We manufacture in Mexico. Anyways, so this is going to be a quick video about that. I hope you enjoy and learn something interesting. Have a great day.
Howdy. This is a circuit I made to replace a high-power Zener diode. When Zener diodes are great, but the powerful ones, 10 watts, 50 watts, are kind of expensive and they're inaccurate. So this thing basically uses a tiny little Zener diode, but it triggers a MOSFET instead, which can take power pretty well. And here's the little circuit right here. It's pretty cute. I did this because I'm having a hard time getting the Zener diodes I need. So I have lots of tiny ones, but not any big ones. It's pretty simple. It clamps the voltage at a certain point. In this case, this is a 4.5 volt Zener diode. So around 4.5 to 4 volts, it makes this transistor conductive. This transistor, which is now 0 ohms, shorts this point to ground. So current's going to flow through here. And more importantly, it's going to flow through this guy, which is going to turn this to 0 ohms, which is going to pull the gate of this MOSFET, NMOS, up to the high rail. And what's cool about this is it works with no power source. It would be more efficient to put in a DC-DC buck converter here and boost the voltage from here up to 18 volts and feed this rail right here. Then your MOSFET would just be on or off. But complexity. So in the name of complexity, I just built it up without that. Here's our Zener diode. Here's our first MOSFET transistor, our second MOSFET, our first transistor, second transistor. This is a resistor, it just makes stuff better. And this is our MOSFET. Here's the gate on top, the drain, and the source. And you'll see, if I give us some power, we're gonna climb in voltage, boom. We're looking at the top voltage, so, you can even see that over here. So I think it tops out at 4. And that's a hard angle too. So Zener diodes are pretty imperfect, and they're like, I'll start zening and become kind of conductive. This is very conductive. So I don't exactly remember what kind of MOSFET I'm using, but I think it's in a 14N30. And this isn't built up for power right now, so it would be destroyed if I left it on at like 5 amps. But if you put a fuse in conjunction with this, high voltage spikes will trip a fuse long before you're trying to protect a 3.3 volt rail, and sometimes you can accidentally touch that to a 12 or 20 volt rail. It will essentially protect that everything on that 3.3 volt rail from getting destroyed. ACDs, Arduinos, computer chips. So by basically shunting the current through this MOSFET instead of letting the voltage climb, and it will probably win out over your power supply, unless you have a car battery, and then you're screwed. But yeah, so I thought you guys might find this interesting. I recorded it because I found it very interesting. I designed it, I built it all in like one go, and it worked really well. So, here's some corner. So at 3.44 volts, which is our operating voltage for the thing I'm trying to protect, we draw 2.2 milliamps. Really good. Zener diodes usually leak about 50, maybe 40 milliamps at that point. And at 4.1 volts, we can do about 7.5 amps. So the rate at which this whole thing changes is really good, because usually you might have a Zener diode, that might become kind of conductive like this. This thing's more like that, so it's much steeper. I like the steepness. All right, hope you guys thought this was cool. And this is how you tune the voltage. This Zener voltage determines the entire Zener voltage. And here's a 20 volt power supply trying to raise the voltage to 20 volts, but the power supply is current limited to 7.5 amps. So we try 7.5 amps and then we hit it 4 volts and then it gives up, and then 7.5 amps and then we give up. Pretty bad for the power supply, but will protect your equipment. 4 volts, A-okay. This is an updated version. Simpler. This is actually better than a Zener diode. I mean, not in complexity, but in response. Here's the source. We're looking at the current through one Zener, which is the current through this guy. Of course, this is the small Zener. So here's the input voltage. It's a 5 volt Zener. You can see here, Zener is 14 amps, while the MOSFET Zener amplification thing is like hundreds of amps, which is kind of ridiculous. So, cool.
So there are some downsides to a system like this. The system I have here, while being practically sharper than a Zener diode, lacks in the turn on and turn off time, specifically the turn off time without a MOSFET gate driver. You could redo this with a gate driver, but essentially it takes about 20 to 5 nanoseconds for the MOSFET to short and turn on and become conductive, and it takes a couple 100 nanoseconds for it to turn off because I'm just using a resistor. I'm just discharging the capacitor bank. So you could go back in and redesign this with a boost converter, maybe on the input rails, that parasitically drains current from the power lines, and then you could boost 2 volts up to like 18 volts and drive your MOSFET gate that way, and it would make a much better system, but then you have complexity and other problems. Someone's calling me.